Welcome. In this video, the short story is that I want to show how to use a ZLayer in the ZIO test environment. So to show how to do that, I think this is different than the last video. What I'm doing here is I create an enumeration called division error, and then I have a single instance of that called division by zero. And then I use that here in the math service trait. So this math service trait is similar to the last one. I think this one might be exactly the same, the add function. And if there's a difference in this divide function, it's that I'm now using a division error as the error right here. So again, this math service is an interface. These two methods are abstract, and you can tell that because there's no equal something over here. So those are both abstract, and then I have an implementation of that math service, and I create that as a ZLayer. So here I just say ZLayer succeed, and then I create a new math service. So everything that I've highlighted here is the instance of the new math service. So I have an implementation of the add function right there, and then I have an implementation of a divide function here. And as I mentioned, if there's anything new compared to the last video, it's that the ZIO fail now uses the enumeration right here. So if b is equal to 0, then you're going to return division by 0 as the error right there. Otherwise, it's going to succeed with an integer in that position right here. And then as I come back up here, I need to be clear that this is creating a new value or variable right here. So it's creating this new variable named math service impl. That variable has this type right here as shown, and then the value of that variable is right here. I need to be clear about the terms variable and value, so that's why I just went through that part right there. So to be clear, we now have this variable with this value, and we're going to use that in just a moment in our test. And now when I scroll down here to our test suite, this is the first option for the test suite. This is not the preferred approach. I think I note that. Yep, right there. This is not the preferred approach, but I want to show this first. It may be simpler based on everything I've covered before. So here I have the first test, and add should correctly add two numbers is what I'm doing. So this code right here is very interesting. It goes off into the ZIO environment and looks for an instance of a math service. And the way it works is that I have provided that service down here. So we have the implementation of the service right here. And now that I have that implementation, I provide that to my test suite right here. So now that that is provided here, I can retrieve that from the ZIO environment right here. Then I have this variable that points to that instance. And then down here, I use the add function of that instance to add 2 and 3 together. That gives me the result. And then I can use assert true here to confirm that that is correct. And then I do the same thing in the second test here, except now I'm going to retrieve the math service again. And this time I'm going to use the divide function. So I get a success there. That one should be 3. And then I do the same thing that I did in the previous video where I try to divide by 0. Then I use .exit right there. And now when I do the assertion over here, I'm checking that with the fails function right there. And I'm checking that the value is equal to the division by 0 right there. So if I did everything right, I should be able to test ZIO test 105 ZLayer like that. And cool, that works as advertised and as desired. But now, as I mentioned up here, this is not the preferred approach. It works, and in the end I can test with assert true, but that's not the preferred approach. So let me comment all of that out. I really just did that to try to show you something that hopefully looks familiar because we've already been through 4 expressions. I've shown you the test part. I've shown assert true. And then I added in the .provide of that implementation here. So in this simpler environment here, I wanted to show how to provide that implementation right there, and then how to access that implementation or how to retrieve it from the ZIO environment once it's been provided. And now I can scroll here and show the preferred approach. And let me move things down so we don't have to see the other code. So you can see in this first line here, I'm doing everything normally. I'm creating a function named spec from a suite, And just like before, I have the dot provide at the end of that suite right there. So I'm providing the math service implementation to this test suite right here. And let me move that down there. And now I have a couple of tests here, and let's just walk through those real quick. So this is a more concise format. It uses assertZIO, and again, we use assertZIO to test effects. And the first argument to assertZIO is the effect that you want to test. So you can see that the effect here is everything that I have highlighted right there. So just like in the previous example above, we use ZIO service with ZIO on the math service. And this portion of that code is what retrieves that math service implementation from our environment. So I provide it here, and then I retrieve it here. Then once I have that instance of it, I name it math service, and then I use it in this code right here. I use that add function. So again, you can think of everything inside this first parameter group as being the effect that you want to test. And then the second parameter group is how you want to test it, the assertion functions that you want to use to test it. And in this case, we say that when this effect is executed and finishes, I expect the result to be equal to 5. So that's how that one works. And the reason I went through explaining all of that is that the second part here is using a shorter underscore format. So in this code here, I use the longer or explicit format. I create a math service variable and then use the arrow to say I want to transform that into this effect right here. And in this example here, I'm not doing this portion of that. I'm just using an underscore down here. So here I retrieve the math service implementation from the ZIO environment. Then I access it right here using the underscore character. So this underscore is a placeholder for that math service variable right there. And then I call divide on it. And just like before, once that effect has run and given us a value, we can say that it's equal to 3. So that's a difference between this example and this one right here. And then in this one, again, I use the underscore syntax. And this time I do the same thing I did in the previous video where we call divide and intentionally have a divide by 0 error right here. So then what we do is we call exit on that, and that gives us the exit value. And that effect that goes from there to there ends with that exit value. And then we can check that the test fails, and then the failure reason is equal to this enumeration value or case right here. So just to reiterate why I did that, I thought that seeing this as a for expression up here would be easier, especially when we're doing the dot provide for the first time and then accessing the implementation from the ZIO environment this way for the first time. I thought this syntax would be easier for you to read and understand. And then once you know how that works, then you can come down here and say, oh, okay, now I can read this better. What Al is doing is accessing the math service implementation from the ZIO environment in that code right there. Then he's creating a math service variable there and then accessing the add function right here. And to me, once you understand that, then you can go back and say, oh, okay, everything between the blue parentheses right here is the effect that is being tested with assertZIO, and then everything that's between these parentheses right here is the assertion test or tests that you're using to test the result of that effect right there. Now, as a little more explanation or perhaps extra credit, I don't know if this will help, but I put these notes together when I was researching ZIO test and using ZLayer with it. So I'm just going to go over these notes real quick. So as I mentioned, ZIO and service with ZIO is used to retrieve a service from the ZIO environment, and that should probably be a capital E right there, ZIO environment, and then you can use that service to perform some operation. So if I scroll up just enough that we could see that, so that's this code right here. And again, we're retrieving a service from the ZIO environment. I like to think of that as a map, and I note that down here, but it's actually more complicated than a map. But basically, you have to provide that ZLayer as an implementation to your environment, and then you can retrieve that implementation like that. So that's what this node is about here. The way this works is it takes a type parameter, in this case that's math service, to specify what service to retrieve. Then it also takes a function as an argument, and the function receives a requested service and returns a ZIO effect. So it's hard to see that function with the shorter syntax, but you can see that function right here when you use that longer syntax. So this is an anonymous function, or a lambda right here, that I'm using along with service with ZIO. So that explained this part, and that was that part right there. Now, in terms of dependency injection, the actual instance of math service is created somewhere else. So I created that up here earlier in the code, that math service implementation. And then the instance is provided to the ZIO environment. Again, that probably should be a capital E right there, using that .provide syntax right there. And then, as I note, ZIO.service with ZIO retrieves that pre-existing instance from the environment. And then when you think about the entire system that we just used up here, when you create a layer and then you use .provide, you're building up what's called the ZIO environment, that is with a capital E. The ZIO environment is a type-safe, immutable data structure that holds your application's dependencies. As I mentioned earlier, I like to think about that as being a map. Conceptually, you can kind of think of that as being a map, but it's more sophisticated than that because you're really just providing this layer for this particular test suite right there. So it is, again, more sophisticated than a map. And actually just jumped ahead there because when you provide a layer, you're adding that layer services to the ZIO environment, but only for the scope of the ZIO effect we just attached it to. And as I mentioned in this case right here, that is the scope of this test suite right there. And finally, ZIO service with ZIO creates an effect that, when run, will access the appropriate service from the ZIO environment. And I kept this last line in here just to be clear that we are still working in the land of effects. So it's creating an effect or a blueprint that has not run, but when it does run, it will access the appropriate service, in this case, the math service, from the ZIO environment. So if I scroll back up here, I will leave you with these notes, and I guess it probably helps to keep that .provide there as well. So if you want to read these notes and make sure you fully understand them, I will leave those right there.